Aloha champions! It's Mr. Chambers here on Monday, April 6th, 2020. Today is a geology lesson covering Chapter 9, Earth's Undersea World. Our objective for today's lesson is scholars will know how the movements of tectonic plates shape and change the seafloor. So going along with this reading, you have this packet, says 13.2 up top, Monday, April 6th, excerpt from Earth's Undersea World. Your end-in-mind goal is to answer the 9 questions in here. It's broken up into 2 parts. The first part asks you to imagine you are a geologist searching for a hydrothermal vent. As you read the following excerpt, answer the questions following the excerpt in complete sentences. So the first 4 questions need complete sentences. Those 4 questions are: 1. What clues tell you that you are close to a hydrothermal vent? 2. How would you get close enough to observe the hydrothermal vent? 3. What would you discover on the seafloor near the vent? And 4. Why is it important to conduct your underwater mission? So the first 4 questions are in complete sentences, asking you, how do you know you're near a hydrothermal vent? Okay. The second part, at the tail end of your packet, says 14.1 up top, and it has 5 questions, a couple multiple choice questions, and a couple grids. I'll go over those quickly before I go into our reading. Question 1 for part 2. Seafloor spreading explains which of the following? A. The presence of mid-ocean ridges on the seafloor. B. Wegener's theory of continental drift. C. The formation of hydrothermal vents. D. All of the above. Or E. A and B only. Number 2 for part 2. Which phrase describes the mid-Atlantic ridge? Is it A. A warm, dark area on the seafloor? B. A long, rugged underwater mountain range? C. A cluster of seamounts? D. A cluster of hydrothermal vents. So we flip further into part 2. For question number 3, you have a list of about 10 sea creatures, and you need to fill in where they live. Do they live around hydrothermal vents or near seamounts? B. Examine some of these animals and explain why might these animals live near these particular seafloor features. Okay. Question number 4, you have a matching where you have the causes and the effects. So match the cause to the effect, what it happens because of these things. And question number 5, on page 84, the author uses a simile when describing the mountain chain formed by mid-ocean ridges, saying it is like the stitching on a baseball. Explain what this simile means. Okay, so those are your questions. It is here in this packet, labeled 13.2, excerpt from Earth's Undersea World. Okay, now I'm going to be reading through Chapter 9 to help give you information. I'll go back and review the packet at the end of this video, just so you know what you need to do. Chapter 9, this is page 82, Earth's Undersea World. Imagine that you are dropping down, down, down into the middle of the Atlantic Ocean. The seawater outside the submersible gets darker and darker. Soon, the light fades completely. Outside is a watery world as black as night. Finally, the sub's lights pick up shapes below as the ocean bottom comes into view. You see lumpy hills and looming peaks of dark volcanic rock. Welcome to the Mid-Atlantic Ridge. The ridge marks the boundary between several enormous tectonic plates. Portions of these plates form the bottom of the Atlantic Ocean. Page 83. Mountains and moving plates. In Chapter 8, you learned some of the ways Earth's slowly moving tectonic plates build mountains. Over millions of years, their movements have created many mountains and mountain ranges on land. Moving plates also build mountains underwater. In fact, there are more mountains on the seafloor than on all of Earth's continents and islands combined. The Mid-Atlantic Ridge is a long, rugged, underwater mountain range. It runs for thousands of miles along the boundary between tectonic plates that meet in the center of the Atlantic Ocean. The plates are very slowly moving apart at this boundary. Remember Alfred Wegener? Wegener proposed the idea of continental drift in the early 1900s. At the time, though, no one knew of any force powerful enough to move continents around on Earth's surface. The theory of seafloor spreading was a big clue in solving this mystery. So as the plates move apart, we have rising magma. The seafloor is spreading, coming in under our continental crust. Okay. Page 84. It was the study of the Mid-Atlantic Ridge that first made scientists consider the possibility of seafloor spreading. They concluded that as seafloor spreads, the continents on either side of the Atlantic are pushed further apart. Scientists soon discovered that the Mid-Atlantic Ridge is just one of many mid-ocean ridges. These ridges are found in all of the world's oceans. Wherever tectonic plates are slowly moving apart together, mid-ocean ridges form a near continuous chain of mountains that wraps around the Earth like the stitching on a baseball. So if you remember, I'm going to pause here. Question number 5 asks you to examine this simile here, like the stitching on a baseball. What does that mean? Okay. Spanning 40,389 miles, the chain of mid-ocean ridges is by far the world's longest mountain range. It is also the most volcanically active. The Mid-Atlantic Ridge is just part of the gigantic underwater mountain chain. Erupting lava has built up high walls of basalt on either side of the rift. The rift itself is nearly as deep as the Grand Canyon. If you travel along the ridge, you'll soon see more than just high walls of dark rock. Okay, so this picture down here, mid-ocean ridges form a near continuous chain of underwater mountains. All of the red in here is all of the underwater mountains under our oceans. Okay. Page 85. Hydrothermal vents. At first glance, it looks like a fire. Black smoke is billowing up from a spot in the ridge. It's not smoke, though. It's searing hot, dark water gushing out of the cracks in the rock. It's a hydrothermal vent. Hydrothermal vents are a bit like geysers in Yellowstone National Park. These deep-sea geysers are much, much hotter than anything on land. Hydrothermal vents form as seawater sinks down through cracks in the oceanic crust. As it nears the magma lying below the crust, the water is heated to incredibly high temperatures. It can reach an astonishing 750 degrees Fahrenheit. The water is so hot that it dissolves minerals from the surrounding basalt. The minerals become part of the hot liquid like salt does when it's stirred into a glass of water. At a hydrothermal vent, the superheated mineral-rich water comes roaring back up through cracks in the crust. It shoots out of the rock with the force of water blasting out of a fire hydrant. When hot vent water meets cold seawater, the dissolved minerals in vent water become solid again. They form tiny particles. The particles make the vent water look like dark smoke. If you're hunting for hydrothermal vents, how do scientists find hydrothermal vents? They hunt from them from ships at sea. Hot mineral-rich vent water moves slowly away from hydrothermal vents. It forms a plume or a cloud of mineral particles that drifts away from the vent, like smoke from a chimney. If the scientists locate a plume, they send down a robotic vehicle, and when it locates the vent, the robot sends pictures back to the scientists. There's more to hydrothermal vents than clouds of hot black water. Communities of amazing and unusual animals live around many of these deep-sea geysers. We have red-topped giant tube worms are the largest animals near vents. Some types of giant tube worms can grow as tall as a person. The vents are also home to ghostly white crabs, football-sized clams, and pale blind shrimp. Scientists believe there are tens of thousands of hydrothermal vents along the world's mid-ocean ridges. Scientists, however, have explored only a handful of them. Finding a new one is always exciting. Scientists often discover new types of animals as well. Page 87. Seamounts and subduction zones. Seamounts are another type of underwater mountain. Seamounts are underwater volcanoes that come in many shapes and sizes. Some are just a few hundred feet high, others tower thousands of feet above the seafloor. Although their tops are still far beneath the ocean's surface. If a seamount grows high enough to rise above the ocean surface, it will become an island. Seamounts can form wherever magma is erupting through the oceanic crust. Many seamounts form alongside mid-ocean ridges or along subduction zones. Finally, seamounts can also form over hotspots far from plate boundaries. The islands that make up the Hawaiian island chain began as seamounts. As we read back in Chapter 4, each island formed over a hotspot that underlies the center of the Pacific Plate. As a result of repeated volcanic eruptions, each island began as a small seamount that grew over time. Eventually, its top broke the water surface, making it an island. Scientists estimate that there are at least 100,000 seamounts over 3,000 feet tall in the world's oceans. Since most seamounts are far below the ocean surface, studying them is a challenge. Scientists have explored a few firsthand, traveling down in submersibles. More often, they send robot vehicles down to do the investigating. No two seamounts are exactly alike. Many are teeming with life, even those that are very deep. Water flowing around these deep-sea volcanoes brings up nutrients from the ocean bottom. Nutrients fuel the growth of tiny single-celled organisms in the water. These in turn become food for larger organisms, including animals that live on and around seamounts. Seamounts are often home to deep-sea corals, sponges, brittle stars, crabs, and anemones. Great schools of fish live around seamounts too. Into the trenches. Seamounts aren't the only undersea features that form along subduction zones. Where one plate slides under another, the seafloor dips down to create narrow, extremely deep valleys. These ocean trenches are the deepest places on the planet. The Mariana Trench in the Pacific Ocean is the deepest ocean trench. It lies just off the Mariana Islands east of the Philippines. The Mariana Trench is hundreds of miles long, but just 43 miles wide. It is like a deep slash in the ocean bottom. The trench's deepest known point is an area called the Challenger Deep. It is 36,070 feet beneath the ocean surface, which is almost 7 miles down. By comparison, the average depth of the ocean is only 14,000 feet. What is it like in the ocean's deepest spot? It's pitch black. The temperature of the water is only a few degrees above freezing. The water pressure is very high, equivalent to having 3 big SUVs pressing down on every inch of your body. Only 3 people have traveled to the bottom of the Mariana Trench. More people have landed on the moon. Several robot vehicles have also made the trip. These visits have provided only brief glimpses of this remote and extreme environment. The Lucky 3. As of 2014, people have traveled to the bottom of the Mariana Trench only twice. The first expedition took place in 1960. The explorers were U.S. Navy Lieutenant Don Walsh and Swiss scientist Jacques Piccard. Their underwater vehicle was the Traced. It took Traced only 5 hours to descend from the ocean surface to the bottom of Challenger Deep. Picard and Walsh peered out a small window onto a part of the planet that humans had not seen before. In 2012, Canadian filmmaker and ocean explorer James Cameron also made the trip. His vessel, Deep Sea Challenger, was a slim one-person underwater vehicle. Cameron's descent took just over 2.5 hours. He did something Walsh and Picard weren't able to. He filmed the descent and the view he had on the ocean floor at 35,756 feet. Okay, so that wraps it up for Chapter 9 in our geology books. As a reminder, this is your packet that you're working on. So it's 13.2, Monday, April 6th. You've got 9 questions, first 4 in complete sentences, explaining how do you know you're close to an ocean vent. The second part, a couple multiple choice questions, a couple of a grid where we have to tell whether these animals would live near a hydrothermal vent or a seamount, and why do you think they would choose these areas. A short matching section, and going back to that simile on page 84, saying that the mountain chain formed by mid-ocean ridges is like the stitching on a baseball. Okay, thank you for tuning in for today's lesson. Tomorrow is a math lesson, and Wednesday will be the mid-unit content exam for the geology. I'll be uploading a video where I'm reading out the questions and the possible answers to help those who need it. Thank you for staying in touch. Please let me know if there's anything I can do to help, and I'll talk to you later. Bye.